I'm Jeff Osmond. I have a long history of plastics experience. I was a mold maker and a tool designer. I worked for companies like Plano Molding. I worked for Furnace Electric, and then I worked for a company called Process Plastic. So I have a very broad range of molding experience. And so what we want to talk about today is we're trying to streamline your design process or development process. And this is pretty much what everyone's done for years and years and years, and done everything in different fashions: electrical design, mechanical design, and then you hand it over, do design validation, which is simulation, and then your technical communication, and then finally you get to the mold production. What we're trying to do is streamline that. So within SolidWorks Plastics and within SolidWorks in general, everything is fully integrated. So you have integrated electrical, mechanical design. You're only working on one model. You're not having to export that to any other model whatsoever. And we're also doing the technical communication. So that gets us everything from conceptual, industrial, but in this case we're going to look at plastic. What we're going to talk about today is 3 different products. It's keeping standard with what we have and how we name everything within the SolidWorks product line: standard, professional, premium. And I'm going to walk through a lot of that with you today. But let's take a look at some of the products. Just take a look around your office right now. Look at your printer. Look at your speakers that you have on your computer. Look at your computer monitor. Everything's plastic. So what we've done is we've given you an option to be able to validate your design options if you're designing that computer monitor, those speakers, that printer. So using SolidWorks Plastics, it's designed for injection molding. That's what we focus on. We predict and avoid injection defects. We're trying to eliminate costly mold rework for you guys. Everything from venting to gate location, or improving your part quality on standard. So we're looking at different things like gate location. So we look at the viscosity of the material and the geometry and find the best gate location. Doesn't mean you need to use that gate location. We're just giving you a suggestion of this is the best way to fill. We will tell you if something's going to short shot. We do track flow front and see how things, weld lines come in, and also meld lines. We'll look at air traps. We do look at fiber direction and velocity vectors to see the flow of your plastic, which come into play when you're looking for strength of material. And we do look at weld lines. Weld lines are bad in 2 ways. It can be structurally bad, but also optically bad. And then sink marks. Sink marks aren't structurally bad, but optically they can be bad. It's something that we can predict for you guys right now. Let's jump into the software. And a couple things I want to talk about. We're going to best practices, something that maybe you didn't learn when you took the class. One of them is gating. So you can do any sort of gate, any type of geometry that you can create with SOLIDWORKS, anything from a D-sub gate to a fan gate to a tab gate, that can be a gate within SOLIDWORKS plastics. So in this case, I created a subgate, a D-sub gate. Basically what I did is just created the geometry I wanted, extruded it, a distance. It doesn't need to be that much. It could even be, a split line. But I extruded it, and to create that and use that as your total gate, what you need to do is, what we'll start out with is the meshing. In this case, I'm using a solid. I always like to use, this is a good tip, the automatic, because what automatic does is gives the software the ability to look at the geometry and will automatically refine the mesh for you, so you don't have to go in and individually pick faces and assign different sizes for the mesh in those faces. If I say automatic, it does it very quickly. So you're not having to spend a lot of time. Let the software do the work for you. Another nice thing is looking at the types of mesh. Sometimes you're not always working within SOLIDWORKS or work with SOLIDWORKS models. You'll have non-manifold topology, you'll have surfaces within solids, that sort of thing. So we give you a full suite of tools that you can definitely work with. So let's create the solid mesh. So once we've created the mesh, to run a study, you basically need three things. You need a mesh, you need a material, and you need a gate location. So we've created the mesh, we need a material. Let's look at the database. So here's how our database is set up. So it's all your different types of materials, but if you do have a material, you can go in and find those materials. So we'll just pick a general material. As you can see, there's a little check mark. What we can do is go in and do the injection location. So normally when you go to the injection location, you pick on a node and you add it. But if you do this pull down here, you have what's called face gating. So I can come in, pick that node and add that location, and then do the injection location. And then all the other faces that I pick now become the gate. So I don't have to actually tell it a gate size, because I'm telling it this whole area. And this would be true, like if you're doing a hot runner, you would do your gate location at the top of the sprue and do your whole sprue and then go from there. So once I do that, I just need to run it. Now I've already run this one, so let's take a look at it. Take a look at a couple different things. Just gonna walk through this. So let's just look at the flow of this right off the bat. I can slow the speed down to take a look at it. Also, I like to use this ISOsurf method because then I can truly see what it looks like loading 3D. Now I know where some weld lines are going to come in, right there. But I can really start watching that flow front and see how things are going to connect. And this helps you during your design phase of, especially if you're doing business in, it doesn't matter if your mold maker is down the street or half a world away, but at least you can have some input of, I want this gate in this location because these weld lines or these air traps will not help us. So if I pause that and look at the weld lines, you can see where the weld lines definitely come in, where the flow front came in. If I run it again, you'll see it real clear. especially this one right here. This could cause a problem, and this one also, structurally. Okay, so valve gates are part of a hot runner system where you want to turn one valve on at a certain time, turn it off, or keep it going, but not turn the other valve on for a while. So in this case, if we come in and take a look at the injection location, if we look at the control valve, we can put control valves wherever. We can automatically add them with 2017. But in this case, as you can see, I'm adding a valve gate from 0% to 50%, and then turning the other one on at 50% to 100% fill. So when I do that, notice how this side is filling first. We haven't turned on the other valve gate. Now it turns on. Now we're going to get some interesting results because we're going to have some different weld lines involved. But this is where during the design process you can make choices of when to turn things on, when to turn things off. The other thing that I like to use is the XY plot. The XY plot is right here, lower left hand corner, and use the measure command to come in, and what I can do is just start picking some areas and see what the differences are. So this is warping fairly heavily, and that would give us indication maybe we need to change our processing conditions. That could be everything from going into setting your packing to your cooling. The other nice thing I like, it's a little lighter, I guess, is the ability to go in and create a report. So within the report, we're getting a lot of different information. In this case, things like your melt temperature, your mold temperatures, those are, and ejection temperature, those are based on your material values. Your volume, it's looking at how much volume you have. That could be important, even in a setup sheet for if you're running a mold for the first time. Your mass. On your flow side, we're looking at clamp tonnage, what it takes, what your cycle time is. On this one, it's 32 seconds total. And that's where we can go in and start changing things, especially on your packing. Your packing time is your longest part of the cycle. It's the pressure and then the pure cooling time. So if we could eject this at 30 seconds and still get the same results, we're saving a ton of money. But that's something you can definitely look at. The pack, what the clamp tonnage, the temperatures, and how much warpage is really happening here, and we can go from there. So let's take a look at what a report looks like. All right. Okay, so your report, you can create a Word document. This is fully customizable. As you can see, it gives you the volume, the mass, the size, gives you material properties automatically. This automatically happens. It's just a push of a button. Melt temperatures, mold temperatures, injection temperatures, your glass transition temperature when things go from plasticized to a solid. Clamping forces. And then you get a full view of all the different results. So let's go in and take a look at a couple other things. Let's talk a little bit about if you're using standard and you want to go to pro or premium. One of the nice things that you can do is insert molding. So in this case, this part's insert molded, and what we can do is go in and take a look at things like temperatures, pressures, how the insert affects the flow. So if we take a look at, let's start just by looking at the flow using that ISO surface, how it's going to flow up these ribs. So I have two types of inserts. I have a brass insert and I have a steel insert. So it's going to take a look at those, and let's take a look at some of the temperatures. I like to use this clipping plane because I can slice it and look at the temperature and measure using that XY plot we talked about, and measure temperatures between what the insert actually is and what the material is. So the material's really hot, the insert's not so much. So we can definitely start looking at that. The other thing we can do within SolidWorks Plastics Premium is start looking at your cooling results. So if I pull up this model, just sketch lines that you can plot out, and we have, much like our material database, coolant database. So we can use different types of materials, everything from water to, if you have something, you can use a user defined, if it's oil or some sort of chemical that you guys have created, we can add that in there. But when we look at the results, we can start looking at temperature, and I can turn on the mold visibility, and then remember using that clipping mode, I can slice this mold in half and start looking at individual temperatures. And maybe I need to move this water line a little bit closer. As you can see, we can measure the temperature here. So I can measure temperatures to see internal temperatures, and that's going to make a difference when I'm looking at like glass transition temperatures to see if it's going to, if my knockout pins are going to push through when I eject this mold. So it's something you can definitely look at on the cooling side. We can start looking at, turn off mold visibility, cycle time. So this is something that you don't have within Plastic Standard or Pro. This is a premium product on SolidWorks Plastics Premium that will give you insight into, especially if you're designing a mold or trying to find more insight into it, you're going to be able to do that within SolidWorks Plastics Premium. We can start looking at average cycle temperature and measure that. As you can see, it's pretty hot down here, so maybe I need to do a bubbler or a baffle down into that area, or maybe it needs to be a beryllium copper insert that crosses path with the water line and will cool that off faster. So that is definitely something that you should look at. Now the other thing with going from standard to pro to premium that you have is warpage, and that is something that you can look at. And even if you're a designer, you should be able to look into the warpage, figure out if what you're designing is going to work. In this case, this is a thermostat, goes on a wall. You want to make sure that it fits into the bezel, the back bezel. So with the warpage, I like to use that measure command, and we can isolate it. So in this case, let's take a look. Let's focus on the Z direction, and we can start looking at in molded residual stresses. We can deform it, so if you really want to see what it looks like bad, that's an extreme, but that is what you're looking at. You have the ability to go in and do an animation of the warp. Now this can also be a sales tool for you guys too, when you're looking to sell something to a customer, or just trying to show your boss that this might not be the best plan. The deformation scale definitely gives you some insight that we need to check into ahead of time. And we can also start looking at with the Pro package, the packing, which we talked about, but looking at things like shear stresses, shear rates, residual stresses, temperatures, the end of freezing. So with SolidWorks Plastic Stand, you basically just have your flow. So you can look at things like the sink marks, you can look at fiber orientation, weld lines, where those are going to happen. Ease of fill, everything fills pretty easily here, and once again you have the ability to go in and check that. I think the end result is really comes down to your report and how that plays out, and how automatic it is for you to create, giving you vital information that can carry along with the project. I thank everyone for coming today. It is the first session of a multi-product seminar, third of this month, and we will look at all the questions and understand what everyone's looking for. Yes, SolidWorks Plastics is a good tool. Some of the practices that I did show, we don't show in the training, so hopefully you gathered at least one or two things from that. But if not, let us know, and we will make sure that we do the right things and get you the information that you need. Like I said, if you have a question, please let us know who your VAR is so we can at least get you in contact with them. But I appreciate everyone's time today.